Go ahead.
Hello again, this is Frank Hunt, frankvhunt.com. That's how you got here, I presume. So, last time I was talking, video number 3, was about the control, right? The control of electricity. And questions came up since then about what if we had this path of electricity come back on the neutral return to another source. Suppose I had another source, the question was, right? And I brought the neutral return back to another source. Would that work? So let me ask you that question for you. Take this neutral return out of here and bring it back to this battery, right? The electrons are going to come along this path. The switch is going to be closed, going to go through the light. This electron is going to come along, they're going to come into another source, right? They're going to be looking for a way to find their way back home. They always want to get back to the place where they started. So these electrons coming back here looking for a way to get back home. Could go through another battery, right? Could come out of this other battery and then go back into the battery they came from. And these are going to be two chemical reactions, two sources, you might say, but hooked up in a way that the electrons flowing through one flows through the next one, goes through the switch, goes through the light, comes back around. So we're going to have twice as much chemical reaction, right? Twice as much capability of producing electricity. And so we could actually have twice as many lights with twice as much battery power. That makes sense to you? Kind of answers your question? So we're going to spend some time going over that kind of stuff about how we can put batteries in series, how we can put batteries in parallel. There's going to be a whole video series about series and parallel. Alright? The next video, this is number 4, the next video after this, I'm going to spend some time talking about the sources of electricity. Actually, maybe I should cover a little bit of that right now. What do you think? The sources of electricity, battery power, like the battery in your car, right? You could even have 2 batteries in your car to have twice as much volume of source of electricity. Another source of electricity that could replace this battery, right, would be something like a mechanical generator of a sort, like the generator underneath the hood of your car, the generator on a motorcycle, the generator on a nuclear power plant. We could mechanically put in here a generator that when it rotates, when that generator is turning, when that generator is rotating, it's getting electrons excited to move. And those electrons are going to be looking for a path to follow, go through the lights, come back, and come back into the generator. We would, of course, skip all of this source and just put a big generator here that would be more than enough power than 2 batteries. We could have generator generate the pressure or the power to get the electrons to flow along this path, to go through this switch, come on the switch leg, go through 1 or 2 lights, come back on the neutral return, and back into the generator, back to where it started, come back to its home, right? This could be a nuclear power plant way down the road, San Onofre, and get these electrons excited to follow that path. So this is a mechanical motion that gets the electrons flowing. So we got the chemical reaction to get electrons flowing, we got the mechanical reaction to get the electrons flowing. We're going to spend a lot of time explaining how that all works. And the third one, the one you guys are really interested in, which you really want to know what happens right now, is the solar power. How about we get rid of this generator and put in here some solar panels to get those electrons flowing with this photosynthesis kind of photon light, getting electrons excited to flow along the path. So you can see why we're going to be spending some time understanding the path of electrons. Okay? That'll be in the next video. Thanks.